Good day, great scientist. My name is Kemi Ariyo. You are welcome to today's lesson. Today, we shall be taking an interesting topic called waves. Have you ever been to an ocean before? I'm sure if you have been to an ocean, you would have observed the beautiful motion of the ocean wave. Or probably, you must have thrown a stone in a bowl of water. What do you observe? If you throw a piece of stone in a bowl of water, you would see the beautiful motion of a wave. Or just try to tie a string at both ends and tap it in the middle. You would also see the beautiful motion of waves. Thank you. My name is Kemi Ariyo once again. Sit down and relax as you enjoy this interesting topic called waves. At the end of today's lesson, you should be able to define waves and wave motion, differentiate between mechanical and electromagnetic waves, 3. Generate mechanical waves, 4. Generate and demonstrate longitudinal and transverse waves. Now, what is waves? A wave is a disturbance which travels through a medium, transferring energy from one point to another without causing any permanent displacement of the medium. If you would remember, I told you the other time, if you throw a piece of stone in a bowl of water, the water inside the bowl will be disturbed. And from the definition I told you now, I said wave is a disturbance. That piece of stone that you dropped in a bowl of water has caused the wave motion, which will transfer energy from the middle of that water to the end, and it will never cause a permanent displacement of the medium. The medium we are talking about here is the water. And what is a wave motion? A wave motion is the process of transferring disturbance from one point to another without any transfer of particles of the medium. Since we cannot define waves, now we can go ahead to know the types of waves. Waves are broadly classified into two types. A, based on the medium of propagation. If we classified waves based on the medium of propagation, we can say that wave is divided into two, which is the mechanical wave and the electromagnetic waves. B, based on the comparison of wave direction with the direction of vibration of the particle. If we classified waves based on the comparison of wave direction with the direction of vibration of the particle, we can say that wave can be longitudinal or transverse waves. Now, like I said earlier, I said waves can be classified into two, based on the medium of propagation, which are mechanical waves and electromagnetic waves. Now, we need to know the definition of a mechanical wave and an electromagnetic wave. What is a mechanical wave? A mechanical wave or mechanical waves are waves that require material medium for their propagation. What do we mean by that? That is, they need a material for the wave to be produced. Example of a mechanical wave are sound waves, water waves, string waves, spring waves. For you to hear a sound, you must have set the air around you into vibration. In that case, the air is the material that is needed for sound waves to occur. For you to produce a water wave, you must have thrown a stone or whatever in the water for you to produce a water wave. Likewise, your string waves. For you to produce a wave in a string, you would have tapped the string in the middle for that to occur. Now, what is electromagnetic waves? Or what are electromagnetic waves, so to say? Electromagnetic waves are waves that do not require material medium for their propagation. As you can see on the screen, we have examples or types of electromagnetic waves. The first one is the radio waves. We have the microwaves. We have the infrared, the visible light, the ultraviolet rays, X-rays, and the gamma rays. Now, all these waves that I mentioned now, they do not require material medium for their propagation. Now, another thing you need to know is a progressive wave. A progressive wave is the wave that travels along a medium, transferring energy from one part of the medium to another. We have two types of progressive waves. We have the longitudinal waves and the transverse waves. Now we need to know the definition of a transverse wave and a longitudinal waves. A transverse wave are waves which travels perpendicularly to the direction of the vibration producing the waves. As you can see on the screen, the arrow indicates the direction of propagation of the wave, and another arrow is indicating the movement of the particle. For transverse waves, the direction of propagation of waves is perpendicular to the movement of the particle. And what is a longitudinal wave? A longitudinal waves are waves which travels in the direction parallel to the vibration of the medium. As you can also see on the screen, the diagram of a longitudinal wave. The direction of propagation of the wave is the same as the movement of the particle. Now we have come to the end of module 1 of this topic, which is called waves. We are going to continue next time. I hope after listening to this lesson, you will be able to, now you can define waves and waves motion. You can differentiate between mechanical wave and an electromagnetic wave. And you can also demonstrate how to generate a mechanical wave. My name is Ariyo once again. Meet me on my YouTube channel. Thank you for listening.